Welcome to Mr. Chalk's Revision Tips. In this video, we will look at solids, liquids and gas. So, when we think about states of matter, we need to consider kinetic theory. So, the kinetic particle theory explains how particles move in different states of matter. Different states of matter particles vary due to the amount of energy they have. The more energy the particles have, the more they'll move around. So we've got solids. Remember, solids, all the particles are fixed in set positions. They vibrate, but they can't move around. Liquids, the particles or the atoms can go and move around. Particles can't be compressed, however, because there's still not really any space between them. And in gases, particles have lots of energy, so they move around and take up a lot of space. But because they take up a lot of space, that means that they can be compressed. Solids are held together in fixed positions and vibrate. Because particles don't move, solids have a definite shape and volume and can't flow. Because particles are already packed closely together, solids cannot be easily compressed, if they can be compressed at all. Because there are lots of particles in a small volume, solids are also very dense. So, the key things when thinking about solids is that they can't be compressed, they have a fixed shape as the particles are held together tightly, they cannot diffuse as the particles are not able to move, they have a high density because the particles are very close together, and they do not exert any pressure on the particles around them. Liquids have more energy than solids. They can flow and take up any shape of a container. They cannot be compressed, however, because the particles are still close together. So the key things to think about when talking about liquids is that they have a fairly high density as particles are so close together. They cannot be compressed because there is very little empty space between the particles. They can diffuse as the particles are able to change places. They take up the shape of a container that they are poured into, as the particles can move, and they can exert some pressure as the particles are able to move and hit the sides of a container. Gas is a state of matter that does not have a fixed shape or volume. Gases have a lower density than the other states of matter, such as solids and liquids. The particles can exert more force on the interior volume of a container that they are in. So the key things to think about when talking about gases is that they have a low density because the particles are far apart. They can be compressed because there is space between the particles. They can spread out because the particles are able to move in all directions. They have no fixed shape as the particles can move about rapidly in all directions. And they can exert a lot of pressure as the particles are able to move in all directions and hit the sides of the container that the gas might be in. So, if we were thinking about describing the movement of particles of helium gas inside a balloon, key things to think about is that they have a range of speeds and they're moving rapidly in different directions. And if you were asked to use your knowledge of kinetic theory to explain the information given in this box below, so the fact that solids have a fixed shape and are difficult to compress, whereas gases will spread out and fill the entire container and are easily compressed. So think about everything that we've been through, then go and check the question answer. So solids, the things that you need to talk about are that the particles are close together, there is no room for the particles to move, they vibrate around a fixed point, they have strong forces of attraction, and the particles are not free to move. Whereas gases are far apart, there are spaces between the particles, so they're easy to compress. They move randomly. There is very, very little force of attraction between the particles, and they can spread out in all directions. If we're thinking about change of state, the kinetic particle theory explains how this can happen. So in terms of the energy level that different states of matter have when they turn in from one state to another. So the changes in state are solids can melt into liquids, liquids can boil into gases, gases can condense back down into liquids, and liquids can freeze into solids. You can also have a gas turning into a solid or a solid turning into a gas by a process called sublimation. So this is where there is no liquid phase. Evaporation is sometimes confused with boiling. They both involve liquids turning into a gas. However, evaporation is a little different because it can occur at any temperature, not just when it's boiling. It only happens at the surface of a liquid, and boiling requires energy to be input, whereas evaporation doesn't. So if we think about the question, the melting point of oxygen is minus 218 degrees, and its boiling point is minus 183 degrees. Predict the state that oxygen will be at minus 200. So oxygen will be a liquid at minus 200 because this is between its melting and boiling points. The diagrams X, Y, and Z show particles arranged in 3 different states of matter. So which state is solid? That would be Y. Which state is liquid? That would be Z. Which state is gas? That would be X. During the day, a puddle of water dries up and disappears. This happens because the particles in the water evaporate. Explain this process. So the process is evaporation. So describe one change in the weather that would cause the puddle of water to dry up faster. It could be any one, from it being more windy, it being warmer, or it being less humid. So density is the mass per unit of volume. It can be measured in several ways. The most accurate way is to calculate the density of a solid, liquid, or a gas, then divide its mass in kilograms by its volume. For most substances, the change from a solid to a liquid state does not mean a big change in volume. This is because the particles stay approximately the same distance apart. So this means that the density of the substance, for example iron, does not change by much when it melts. When a liquid changes into a gas, however, the space in between the particles increases significantly. So this means that the gas takes up a lot more space, so therefore its density will decrease dramatically because the volume is increasing. So if we were investigating this, we could record the mass of an object, we could go and put it into a beaker of water or a eureka can. We could measure the amount of water that the piece of material displaces, and that would give us a measure of its volume. So a student wanted to go and determine the mass of a rock. So the volume of a piece of rock was 18 centimeters cubed. The student measured the mass of a piece of rock to be 48.6. Use the equation above to go and calculate its density. So its density would be 48.6 divided by 18, which would give you 2.7 grams per centimeter cubed. If we were looking to describe how we could go and measure the volume of a piece of rock, you would need to go and describe the practical that we've just seen on the previous slide. So you would go measure the volume of water that a piece of rock displays, and that would give you the volume of the rock.
Thanks for watching.